Hi everyone and welcome back to another lab. In this lab, we are going to cover how you can configure and verify IPv4 address for default and static routes. We will start with an overview of what a default route is and what is a static route, and also we are going to explain why they are essential. We will then go through the lab topology and lab objectives. Next, we will then follow this with the lab tasks, and once we get to that stage, we can then go through the lab solution. By the end of this video, you will not only understand the importance of default and static routes, but also you will be able to configure and verify them in your own network environment. So first things first, a default route is a fundamental concept in networking, serving as a catch-all path for any traffic that doesn't have a specific route defined in the routing table. In a network, routers use routing tables to determine the best path to forward traffic or forward packets towards their destination. Each entry in the routing table specify a destination network and the next hop address, or the interface to use to reach to that network. However, it is impractical to have a routing table entry for every possible destination on the internet or a large network. And this is where the default route comes into play. In practical terms, a default route is often used to send all outbound traffic from a local network to the internet. For example, in a home or a small office network, the default route usually points to the internet service provider or the ISP's router. On the other hand, a static route is a manually configured entry in a router's routing table that defines a specific path for traffic to follow in order to reach a particular destination network. Unlike dynamic routes, which are automatically updated by routing protocols, such as OSPF, EIGRP, or BGP, which, by the way, we will cover those topics in future labs. But based on the current network topology and conditions, static routes require manual setup and adjustment by a network engineer. And the primary purpose of static routes is to provide precise control over the routing of traffic within a network. They are particularly useful in a small or stable networks where the topology does not change frequently, as well as in larger networks for defining specific paths for certain type of traffic or for creating backup routes. So regarding the lab topology, we have a couple of servers that are somewhere on the internet. Hypothetically, we have server 1 and server 2. Server 1 has an IP address of 203.0.113.20, whereas server 2 has 203.0.113.40. And we can see here that we have the headquarter router 1 router that is connected to branch 1 router 1, which hypothetically, let's say this router resides in Cambridge, whereas the headquarter resides in London, and the headquarter router 1 is also connected to the ISP via gig ethernet 001. Headquarter router 1 is connected to branch 1 R1 via gig ethernet 000, and headquarter router 1 is connected to headquarter switch 1 via gig ethernet 002. And the LAN network for the headquarter router 1 is 172.16.10.0/24, and that network will be part of VLAN 100. And you can see PC3 and PC4 will be part of that network, and both of these PCs are connected to the headquarter switch 1. So on the other side, we can see that the network for branch 1 router 1 will be 172.16.20.0/24, and this LAN network will be part of VLAN 101. And we can see that PC1 and PC2 are part of that network, and both of these PCs are connected to branch 1 switch 1. And the objectives of this lab is to demonstrate the configuration and verification of IPv4 default and static routes, and to understand the difference between them, so that you can apply each method according to your business needs. We also need each PC in VLAN 100 and VLAN 101 to be able to communicate with each other and communicate with server 1 and server 2 from the internet. And just to let you know that all PCs are pre-configured with the appropriate IPv4 address settings and default gateway. So regarding our lab tasks, we will start our list of tasks by configuring all access ports on both switches, where we will configure the appropriate VLAN for each site and assign each port with the respective VLAN. Then we're going to jump into step 2 and step 3, where we are going to perform some basic configuration on branch 1, router 1, and headquarter router 1 as well, where we are going to configure each connected interface with the appropriate IPv4 address settings. Once we completed this, we will then do some connectivity tests, and then we will move to step number 4, where we are going to configure a default route on branches 1, router 1. Then we will do the same for the headquarter router 1 as well. But we will add a static route so that traffic distant to the branch 1 office gets routed accordingly. In the interim, we will go through the routing table and explain the output in details. Finally, once we completed all steps, we will then perform a ping test from PC1, PC2, PC3, and PC4 to server 1 and server 2. If the ping was successful, then we will go ahead and save the configuration, and that will be the end of the lab. If not, then we will have to do some troubleshooting and fix the issue here and there and accordingly. Okay, this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. I have added the lab document in the video description as usual, so you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to tackle the first task, and I'm going to jump into the headquarter switch 1, and I'm going to go to the CLI, and then I'm going to go to config terminal, and from here I will create a new VLAN. So I'm going to say VLAN 100, and I'm going to name that VLAN. I'm going to say VLAN 100, and then I'm going to jump into interface gig Ethernet 01. Sorry, 02 actually. And first things first, I'm going to set the description to link to HQ underscore R1, and I will set the mode to access. So I'm going to say switch port mode access, and then I'll set the VLAN switch port access VLAN 100. Now that we've done that, we can then configure the interfaces that are pointing or linked to the end hosts. So I'm going to exit this, and I'm going to say interface range, and then fast Ethernet 0/1-2, and I'm going to say switch port mode access, switch port access VLAN 100. And also I'm going to set the description, so I'm going to say link to end hosts, let's say. If you want to be specific, you have to go through each interface and create a unique description per interface. Now that you've done that, I will just end this to go back to user privilege mode. And we can do the same thing on the branch 1, switch 1. So I'll go back to my topology, and I'll click on the branch 1 underscore switch 1, and then go to the CLI and do the same thing. I will start by creating VLAN 101, and I'm going to name that VLAN with VLAN 101. Exit, and then I'm going to configure the interface gig Ethernet 0/2 that is connected to branch 1 underscore R1 or router 1. So I'll set the description first, and I would say link to branch 1 underscore R1, and then I'm going to say switch port mode access, switch port access VLAN 101. Next, let's configure both interfaces that are connected to the end hosts. So fast Ethernet 01 and fast Ethernet 02. We can do them individually, but to save time for the sake of it, we use the range command. So I'm going to say interface range fast Ethernet 0/1-2, description link to end hosts. And let's set the mode to access. and then switch port access VLAN 101. So now that we've done this, let's jump into the in-flight checks. So I'll go back to the other switch, which is the headquarter switch 1. And I will start the in-flight check with this command, show interface status. And you can see that we have created three descriptions for our connected interfaces. You can see the fast Ethernet 01 and fast Ethernet 02. Both of them are connected, part of VLAN 100. And also you can see the link description for each interface. On the other hand, we can look at the Gig Ethernet 02 that is connected back to the headquarter router 1, and right now is not connected. And the reason why it's not connected is because the other end of the link is in the admin down. But we can see that this is part of VLAN 100, and we are going to fix the no connectivity issue when we tackle the next task. Next, let's check the VLAN database. So we can say show VLAN brief. We can see from this line that the VLAN ID is 100, the VLAN name is VLAN 100, and the current active ports are the three ports that we configured: Fast Ethernet 01, Fast Ethernet 02, and Gig Ethernet 0/2. Next, if you want to look at the current configurations, so you can issue the show running type section, and then you can just hit the 0/0 or 1, and then $, and then that will show you fast Ethernet 01 interface config. And you can see these are the lines that we have entered. If you did the same thing for fast Ethernet 02 and Gig Ethernet 02 as well, that will show you both of the interfaces at the same time. Next, we can issue the show interface fast Ethernet 0/1, and then we need to include the word switch port at the end. So what you see on the screen is the output for layer 2 information related to interface fast Ethernet 02. So you can see the name here. You can see the switch port is being enabled, which means it operates at layer 2. And right now you can see the operation mode of that interface is configured as static access. And also you can see that this interface is part of VLAN 100. Next, if you want to look at the forwarding state for each interface, we can say show spanning tree VLAN 100, and that will show you the forwarding state for each interface. Right now we can see fast Ethernet 01, fast Ethernet 02, but we can't see Gig Ethernet 01 or 02, sorry. And the reason being is because, as I mentioned earlier, the other end of the link is actually admin down. So if I issue show IP interface brief, you will see that fast Ethernet 01 and 02 are in the up state. However, Gig Ethernet 02 is actually down. So the physical layer is down as well as the layer 2. So with that being done, let's jump into the other switch. And let's just quickly verify our configuration. So I'll be quicker this time. So I'm going to say show interface status. We can see that these two interfaces are in the appropriate VLAN, and the same applies for this interface as well, Gig Ethernet 02. If we say show IP interface brief, again, these two interfaces are in the up state, and this one is also in the down state. And again, because the other side of the link is admin down, and we will tackle that next. And finally, let's just check the VLAN database. So I'm going to say show VLAN brief. And again, you can see that we've created VLAN 101. We named it VLAN 101. And the current ports that are assigned to VLAN 101 are fast Ethernet 01, fast Ethernet 02, and Gig Ethernet 02. So next, let's tackle step number 2, where we are going to perform some basic configuration for branch 1 underscore R1, which is the router that is connected to branch 1 underscore switch 1. So I'll go back to my topology and I will click on the branch 1 underscore R1 router, go to the CLI, and then from there I'll go to enable mode and then configure terminal. and then I will configure the interface that is connected back to branch 1, switch 1. So I'm going to say gig Ethernet or interface gig Ethernet 0/0/2. Let's set the description first. So I'm going to say link to branch 1 underscore switch 1. And let's set the IP address to 172.16.20.10/24. So that's going to be 255.255.255.0. And also we are going to enable the interface. So we're going to say no shot. And now we can see that the interface actually has gone up. Next, let's do the same thing on the interface that connects back to the headquarter R1 or router 1. So I would exit the interface level configuration, and I'm going to go back to the interface gig Ethernet 0/0/0 level of config. And from here, I will set the description. So I'm going to say link to HQ underscore R1. I will set the IP address to IP address 10.0.0.2. And the subnet mask is going to be /30. So that is going to be 255.255.255.252. And also we need to enable the interface. So we're going to have to say no shut down. And right now is only up. And this is the physical state for the local interface. Obviously the data link layer or layer 2 is down because the other end again is in the admin down. But we're going to tackle that next. So let's perform some in-flight checks quickly. So if I say show IP interface brief, you can see that this interface that we just configured with 10.0.0.0, 10.0.0.2 is in the up-down state, whereas the gig Ethernet 002, which have 172.16.20.10 IP address that connects back to the branch switch 1 or branch 1 switch 1, is in the up state. Okay, so what I'm going to do next, I'm going to perform some local connectivity between PC1 and PC2 just to make sure that we have the right configuration and we have put everything as expected. So I'll go back to my topology again and I will click on PC1, go to desktop, and then go to the command prompt. And from here, I can issue the ipconfig to reveal the IPv4 address information. And let's try to ping the default gateway, which what we configured on the branch 1 router 1 interface, which is gig Ethernet 002. So I'm going to try to ping that, which is ping 172.16.20.10. And you can see that we have successful ping. So now let's ping PC2. So I'm going to say ping 172.16.20.2. And we have also reachability between the default gateway as well as between PC1 and PC2. Next, we're going to jump into headquarter R1 to perform some basic configuration, much like what we did with branch 1 R1. So I'm going to go back to my topology, go to headquarter R1 stencil, and then go to the CLI and do the same thing. So I'll go to enable mode or user privilege mode, and then from there go to configure terminal, to go to global configuration. And from here, we are going to tackle interface gig Ethernet 002, which the link that connects back to headquarter switch 1. So I'll say interface gig Ethernet 0/0/2. Let's set the description first. So I'm going to say link to HQ underscore switch 1. And then I'm going to set the IP address with the appropriate IP address or appropriate network. So it's going to be IP address 172.16.10.10/24. So it's going to be 255.255.255.0. And also we need to enable the interface. So we're going to say no shutdown. And you can see the physical layer is up as well as the data link layer is up. So now that we've done that, let's move into the other interface, which is connecting back to branch 1R1. So I'm going to hit exit and I'm going to say interface gig ethernet 0/0/0. Again, let's set the description. So I'm going to say description link to branch 1_R1, and I'm going to set the IP address with 10.0.0.1/30. So that's going to be 255.255.255.252. And we're going to say no shut. And you can see that both layers are in the up state. So I'm going to actually do ping 10.0.0.2 to ping the other side of the link. And I'm hoping that we get successful ping. As you can see, we just got successful ping. Now that we've done that, let's do the same thing, but for the interface that connects back to the ISP. So I would say interface gig ethernet 0/0/1. And I'm going to set the description to say link to ISP. And then I will hit enter. And then I will set the IP address for 203.0.113.1. And that again is going to be /30. So it's going to be 255.255.255.252. And again, we mustn't forget that we have to enable the interface because all routers interface by default are in the admin down. So we're going to say no shutdown. And we're going to end that. And then let's just do some in-flight checks. So I'm going to say show IP interface brief. And you can see that we have configured 3 different interfaces. The first interface that connects back to the branch 1, router 1, is in the up state. And the second interface that connects to the ISP, which is also in the up state. And the third interface is connected back to the headquarter switch 1. Next, I want to issue the show IP route command. So I'm going to say show IP route. It is crucial to understand the output of the routing table. So when you issue the show IP route command, it provides a comprehensive view of the routing table. It includes various codes, the gateway information, and the network entries. So the top section of the output, where I'm highlighting, lists various codes that help you understand how to read and interpret the routing table entries. And these codes indicate the source or type of each route. Each code helps identify the method by which a route was learned or configured. So for example, the L stands for local, and that means that the address assigned to the router's interface. And the C stands for connected, and that means directly connected network. Whereas the S stands for static, and it means a manually configured static route. And if you look at this one, which is R, which means RIP, and RIP means route learned through the routing information protocol. That is a dynamic protocol, which we will cover in the future videos. And also you can see the B for BGP, and BGP means routes learned through the border gateway protocol. Again, that's another topic that we will cover in the upcoming sessions. The second section that I want to highlight is the gateway of last resort. And at the moment, you can see that is not set. And it is also known as the default gateway. And this is used when the router has no specific route for a destination in the routing table. And if not set, it indicates that there is no default route configured, much like what you see on the screen. However, later on, we will configure a default gateway for HQ_R1 router, which is the router that we are on at the moment. And you will look at what that would look like in the routing table. And then finally is the network entries, which is the section that I'm highlighting. And this section lists all the network entries that the router is aware of. And each entry includes the network address and its subnet mask. If we have configured a static route or dynamic routing protocol, we can then find something called administrative distance and metric. And these values indicates the reliability and the cost to reach that network. And also you will see the next hop, which is the IP address of the next hop router or the directly connected interfaces. So remember, if we look at the show IP interface output, you can see that we have configured 3 different networks. And what you see on the routing table, also 3 different networks. So the first section of that section, you can see that there are 3 entries. The first entry indicates that this is the class full of the private IP address class A, which is 10.0.0.0/8. And you can see that we have a couple of entries related to that particular network or prefix. The first one it says or indicates is connected, which means this network, which is /30, have pretty much 4 different IP addresses. The first IP address is the network address, which is 10.0.0.0, and second IP address, which is the host IP address, and that would be 10.0.0.1. And you can see that this is actually configured locally from the second line. And then the third IP address within that range or within that network is the 10.0.0.2. And then finally the broadcast, which is 10.0.0.3, which means if I try to ping 10.0.0.2, the router will look at the routing table and then it will use gig Ethernet 000 as an outbound for the traffic. And then the second line, or the third line, as you can see on the screen where I'm highlighting, that indicates that this prefix or this IP address, which is 10.0.0.1, is locally configured on the interface of gig Ethernet 000, as you can see on the screen here. And if we apply the same pattern, you will understand the second network and also the third network. So if we try to ping, for example, PC3 or PC4, the router would actually use gig Ethernet 002 to reach to that network. So if I say ping 172.16.10. let's say 3 for PC3, you should be able to have successful ping, which you can see on the screen. Okay, so now let's do some further in-flight checks. So I'm gonna actually examine the current configuration of the router. So I'm gonna say show running config pipe section, and then I'm gonna include 0.0.0, and that will include also the $. And you can see that this is the current configuration for gig Ethernet 000. And if I did the same thing, but this time for 01, you can see this is the interface that is pointing or is linked to the ISP router. And then finally, the interface that connects back to headquarter switch 1. These are the configurations that we just did. Next, let's initiate a ping to test connectivity to branch 1 R1, as this is one of the requirements. So I'm going to say ping 10.0.0.2. And again, that should be successful. And now let's ping the ISP IPv4 address. So that is going to be 203.0.113.2. And again, we get successful ping. And then finally, we need to log into one of the PCs. So let's go to PC3 and initiate a ping between PC3 and PC4. So let's do that. So I will go back to my topology, click on the PC3 stencil. I'll go to desktop and command prompt. And from here, I can issue the ping command with 172.16.10.4. since it is PC4, and then I'll hit enter, and you can see straight away that we have an instant reply. Okay, next we are going to initiate a ping from PC3 to PC1. So I'm going to say ping 172.16.20.1. And as you can see, the ping have failed. And when you see a destination unreachable message, it indicates a routing issue between the devices. So the destination unreachable message typically arises from a router indicating it does not have a route to the destination network. And in this particular case, the primary issue is the lack of routes in headquarter router 1 and branch 1 router 1 for the networks involved. So for instance, HQ_R1 router needs to know how to reach PC's 1 network. And if the headquarter router 1 does not have a route to PC's 1 network, it cannot forward the packet towards branch 1R1. And when PC3 sends a ping to PC1, the packet reaches HQ_R1, and then that router checks its routing table and finds no route to PC's 1 network, leading it to drop the packet and possibly send an ICMP reply back saying destination unreachable. On the other hand as well, branch 1R1 needs a route to PC3 network to facilitate the return traffic. If branch 1R1 does not have a route to PC's 3 network, it will not know how to send the reply packets back to PC3. Even if the headquarter router 1 had a route to branch R1 and forwarded the ping packets, branch 1R1 would receive them but would be unable to send the reply packets back to PC3, resulting in a failed ping. So in order for us to resolve this problem, we would need to ensure that both routers, which are the headquarter router 1 and branch 1 router 1, have correct routes for each other's network. So what we would need to do, we would need to jump back into branch 1 R1, which I'm going to do now. So it's going to be branch 1 R1. I'll go back into global config, and we will need to actually create a default route. You would just need to issue the IP route command, and then followed by 000 for the destination address. If I just erase that and question mark that, you would see that this is the destination prefix, and you can set it with 0.0.0.0, and then the destination prefix mask, which is also going to be 0.0.0.0. And then if you question mark that, it would ask you what is the forwarding router's address, or what is the next hop. So in that case, we know that the next hop is the headquarter R1 or router 1, which has an IP address of 10.0.0.1. And then we hit enter. And if I end this, and we can just do some in-flight checks. So I'm going to say show run pipe section IP route. You can see that this command has been taken. And also to do some further in-flight checks, we can say show IP route. And what you see on the screen here is the gateway of last resort has been set. So that means under the branch 1 router 1, if I have another network, let's say I have got another VLAN, let's say 102, and then under that VLAN, I'm going to have a new subnet, which is 172.16.30.0/24. That will then use the default gateway, which has been set here, to reach the other network and also to reach the internet eventually. And also what you can see from the network entries, an S with an asterisk, and that indicates that this is the default route. S means static route, and the star or the asterisk means a default route, as you can see from the screen here. And you can see that this actually is set to any destination prefix and any destination subnet. And that is going to be via the 10.0.0.1 or gig ethernet 000. So now that we have done half of the job, let's say, let's go ahead and initiate another ping, and let's see the behavior of the current network topology. So if I go back to my PC1 and I try to actually initiate a ping request or a ping to 172.16.10. Let's say we want to ping PC3, so I'm going to set the number 3 and then hit enter. You can see that the ping has failed, and if you want to actually find out where the problem is, you can use a command called traceroute, or trace RT and then set the IP address, which is going to be 172.16.10.3, and then hit enter. I actually had to cancel it, and the reason being is because it's not going to work. And the reason being is because the traffic goes all the way to the branch 1 router 1, which is 172.16.20.10, which is the branch 1 router 1. And then branch 1 router 1 will then forward the traffic to headquarter router 1, but then headquarter router 1 wouldn't have a clue how to send the traffic back to branch 1 router 1. And that's why it fails. So what we would need to do next, we would need to actually jump back into the headquarter underscore router 1 and do the same thing. So let's do that now. So I'll go to global config. I'm going to say config terminal. And from here, I would say IP route 172.16.20.0. And that is going to be 255.255.255.0. And I will set the next hop address to branch 1 router 1. So it's going to be 10.0.0.2. Now that is being done, let's just end this and then do some in-flight checks. So I'm going to say show running config pipe include route. And you can see this is the configuration that we just pushed to the router. And if we issue the show IP route, okay, so what you see on the screen is that there is a new record that have been added to the routing table. And if we were to read that, you can see that S stands for static. And the network address or the prefix that is being configured is 172.16.20.0/24. The current administrative distance is 1 since it's a static, so it's more believable than any dynamic route, unless obviously you override that and you can manually change this. The current metric is set to 0 since it's a static route, so there is no way for the router to calculate the metrics, and it is via 10.0.0.2. So if I want to reach that network from router 1 or headquarter router 1 perspective, we would have to actually use this next hop address, which is 10.0.0.2. So now that we have done this, let's go back to PC1 and try to initiate the same command or the same ping command. So I will just go back to PC1 and I will up arrow multiple times to initiate a ping request. And I will hit enter. And now you can see that there is actually connectivity between PC1 and PC3. If I up arrow that and issue the ping for PC4, we also have reachability and connectivity. Okay, so next let's jump into step 5, where we would need to log back into headquarter router 1 and configure a default route with the next hop address of the ISP IP address. So let's do that. So I'm gonna go back to HQR1, go to global config, and from there I would say IP route 0.0.0.0 and then 0.0.0.0, and then the next hop would be 203.0.113.2. I'm going to end this, and again I'm going to examine the routing table. So I'm going to say show IP route, and you can see that this entry has been populated, and also you can see that the gateway of last resort is 203.0.113.2, which is pointing back to the ISP router. That means if I initiate a ping request from PC1 or PC2 or PC3 or PC4, there will be connectivity to server 1 and server 2. So let's do that quickly. So I'm going to go back to PC1, and from there I would initiate a ping request to 203.0.113.2 20, which lives somewhere hypothetically in the internet. And that's pinging server 1, by the way. I'm going to hit enter, and you can see that we have reachability and accessibility. If I did the same thing for server 2, which I think is 40, there is also connectivity and reachability. If we were to issue the command trace route 203.0.113.40, let's say. So what you see on the screen here is that we had to use 3 hops to get to the destination. So the first one is branch 1, router 1, and then the second router is the headquarter router 1, and then the third router is the ISP, and the trace was complete. And I guarantee you, if we repeat the same test for PC2 and PC3 and PC4, you will have connectivity and reachability. So with that being done, this is the end of the lab. We can go ahead and save our configuration. And that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. So remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.